Okay, in your external you are going to have to sketch the gradient function of a graph. And we can also practice a little bit of deriving to make sure we're correct. So here's our function. What does the gradient graph look like? Let's take this point here. What's the gradient? The gradient at that point is 1. Let's take this point here. What's the gradient at that point? It's also 1. What's the gradient at this point? Oh, it's also 1. So the gradient function is going to be y equals x. However, because we're deriving it's the gradient function, we would actually call it f dash of x equals 1. Now we could have just derived this by our rule of lower the power. Remember, x to the power of 0 is 1. So the x is the same as 1x to the power of 1. And our rule is a n to the x. When we derive, we go, get it right, a x to the n. We go a n x to the n minus 1. So we basically multiply the number in front with the power. So 1 times 1 is 1. And then we take the power down by 1. We've got x to the power of 0. X to the power of 0 is 1, so the answer is 1. Okay, there we go. Sweet. Next question. Now, let's sketch this. Where is the gradient 0? The gradient 0 here. Here the gradient's negative, isn't it? And here's the gradient's positive. What's approximately the gradient there? 1.5? Maybe 1.5. So at this point, the gradient, is 1.5. So there. Yep. Better get my pen back. There we go. 1.5. And we actually know a parabola goes to a line, so I'm going to roughly draw it through like that. So here we've got negative gradient under the line, and here we've got positive gradient above the line. How would I actually derive that? Okay, I'm going to leave the 0.2 at the front. All that mess. So I'm going to have 0.2, and then I'm going to expand this here. So I'm going to have x squared minus 3x plus 4x, so that's going to be plus x minus 12. The whole thing's times by 0.2, so 0.2 x squared plus 0.2 x minus 0.2, that's going to be 2.4. So that's my f of x. So what's my f dash of x? F dash of x, my gradient function, 2 times 0.2, 0.4. Take the power down, 2 minus 1 is 1. And I don't have to write the 1. Here you get 0.2 because it's 1 times that. Take the power down, that'll be x to the power of 0, which becomes 1. And remember that 2.4 is actually 2.4 times x to the power of 0. So the 0 times that makes it disappear, so the rule still applies. So there we have our answer, 0.4x plus 0.2, and that is correct, just a different format. And how good was my drawing? Oh, disappeared, never mind. On to the next one. This one here. How am I going to draw the gradient function? Just sketch it. Here, the gradient's 0. Here, the gradient's 0. Here, the gradient's positive. Oops, that's positive. Here it's negative, and here it's positive again. And I know that a cubic becomes a parabola. So I know I'm going to have this sort of shape here. But how low should I go? What's my maximum negative gradient here? That looks about 2, so maybe it should have gone closer to negative 2. Negative 2 gradient. There we go, a little bit less. This you're not going to get marked down on. The important bit is that when the gradient here is 0, that's where it cuts. And this is roughly right, and that a cubic, the right way up, has become a parabola. So that's sweet. This one here, what's the gradient? Gradient is constant. The gradient is -3. So the gradient function, every place on this line has the same gradient. So our gradient function is -3. This one here, gradient function is -1. This one, doing our sketch. Here, gradient is 0. Here, gradient is 0. Here it's positive, then it's negative, then it's positive. Let's have a look at that. That's only going about 2, so this is a bit deep. It is more accurately here. Okay, so the important thing being those 2 points there. Did I get those right? Looks like it. At 0 and 5, 0 and 5. Nice. Okay, this next one. What's our gradient here? If we pick 2 points, it's basically, well, it's 0.3. So our gradient graph is 0.3. Okay, so that's just a bit of a recap on what we actually did today. We also did a little bit of integrating, but that might be best left out. It was just fun.